Hey folks, welcome back. This is arrays number 3. And so today we are going to take a look at some more things that you can do with arrays. And we're going to look at a new kind of loop called a for each loop. And we are going to work a number of examples with arrays. So without further ado, let's start with the for each loop. So we mentioned that there were 3 kinds of loops when we were doing repetition. We had the while loop, we had the do while loop, and then we had the for loop. And the difference was that the do and the while and the do while loops, we don't know how many times they're going to go. They're going to go until a condition is met. Whereas a for loop is going to go a set number of times. We generally know up front that it's going to go 9 times or 12 times or 15 times or whatever the case may be. So the fourth kind of loop is a specialized kind of for loop. As a matter of fact, in Java, it's literally just a for loop that takes different parameters. So a for loop or a for each loop is used when you want to go over an array. So what it does is it automatically iterates, and iterates just means that it's going to go multiple times, once per cell of the array. It automatically iterates over all of the cells of the array for you. So generally what you would have written in a for loop is something along the lines of for I equals 0, I less than the array.length, I plus plus, and then inside the array you would do something where you take one value out of the array and put it into a temporary variable, and then you do whatever it is you want to do with that variable, print it or change it or search for the high or the low or whatever it is that you're doing. Well, a for each loop just automates that process for you. So instead of having to do for I equals 0, I less than the size of the array, you just tell it iterate over this array, and then it will do it automatically. It knows how big the array is. It automatically pulls one cell out at a time and shows you what's going on with that cell. So the syntax for a for each loop looks really similar to the syntax of a for loop. And as a matter of fact, that's probably one of the more confusing things about it. So this up here is the syntax for a for each loop. You'll notice it still starts with the word for. That hasn't changed. And there's still a set of parentheses like there was in a for loop. But in a for loop, you would have said something like for int I equals 0, I less than 3, I plus plus. And there were 3 parameters, and they were separated very specifically by semicolons. Remember that? There was a semicolon between each of the 3 parts. The first part was the initialization, the second part was the test, and the third part was the increment or decrement. So in a for each loop, it works slightly differently. You're going to have a type and a variable, and then you're going to have a colon, and then you're going to have an array. So the array is literally going to be the name of the array. And so, for example, if you say int square brackets my array equals new int 5, then this is going to be my array. So it's the name of your array is what's going to go here. On this side, the type of the array has to match the array that you have over here. So if you say that it's an array of integers, then the type that's going to be here is going to be int. And the array name is going to be my array. And then a variable name is put in between the two. And you can make the variable name whatever you want. I'm going to make it x in here because that's a terrible idea. And so what's going to happen is it's going to take each of the values out of my array, and one at a time it's going to assign them to a variable called x, and then you're going to go through the loop. So a for each loop is nothing more than a specialized version of a for loop where it automatically knows how to go over an array. All right, so let's take an example. So we have here an array of strings. So this is a string array, and we know that because we said string square brackets equals new string square brackets. And we have, we called it words. So words is the name of the array. And I went ahead and initialized it with 4 strings. So Bilbo Baggins the Hobbit. All right, so each of those strings is now in a cell of the array. And if we look at the picture of the array that we've got here, you can see that it's an array with 4 cells, 0, 1, 2, and 3. In cell 0, it put Bilbo. In cell 1, it put Baggins. In cell 2, the word the. And in cell 3, it put the word Hobbit. So this is how you initialize an array. We've seen this before. That's nothing new. But then I could say for string 1 word colon words. So words again represents the name of the array. That matches that. And then string matches the type of the array. That has to be true. And then 1 word is just a variable that I made up. I called it 1 word. And I called it 1 word because each time through the loop, it's going to hold one of the words in the array. The first time through the loop, it's going to hold Bilbo. The second time through the loop, it's going to hold Baggins. And the third time, it's going to hold the. And the fourth time, it's going to hold Hobbit. And then the loop is automatically going to stop. It just does all the translation for you without you having to do anything else yourself, which is pretty cool. All right, so we're going to trace a for each loop. So we're going to start off at main, and we're going to do the usual thing that we've always done here, which is we're going to have our variables and we're going to have our output. And what we're going to do is we're going to start off up at the top with our little pointer that tells us where we are in the code. So we come in, and the very first line of code produces an array, and that's the same array that we've seen before. So there it is over in the variables area. So words has 0, 1, 2, 3, Bilbo Baggins the Hobbit. All right, so now we're going to start our for each loop. So when we get to the beginning here, what it does is it checks to make sure that words is an array. It then checks to make sure that it's an array of strings, and assuming that both of those things were true, then it creates me a variable called oneword, and you can see that that got done down here, and it immediately sets the value from the first cell into that variable. So right now, oneword is equal to Bilbo, and then it's going to proceed through the entire loop, and while it's going through the loop, we have a variable called oneword that we can do anything we want with. And so, for example, if I come up here, it's going to print Bilbo when I print oneword. When I reach the bottom of the loop, just like any other loop, it's going to return me to the top of the loop, and then it's going to do whatever the loop tells it to do. In this case, what's going to happen is it's going to automatically move on to the next cell, which is cell number 1, and it's going to automatically change the value of oneword for you. So oneword is now equal to Baggins. And once that has completed, we're going to go back into the loop again. We're going to print out Baggins because that's what the print statement says to do. We're going to reach the bottom of the loop, which is going to send us back up to the top of the loop. And when we get to the top of the loop, it's automatically going to move over to the next cell, pull the value into oneword, and go back through the loop again. So on the third iteration of the loop, it prints out hit the bottom of the loop, back up to the top, automatically pulls Hobbit into oneword, and then we go back into the loop again, we print out Hobbit. Now, what's interesting is what happens the next time through. So when we hit the bottom of the loop, it again goes back up to the top of the loop, but when it gets to the top of the loop, it realizes there are no more cells. So since there are no more cells in the array, and it knows how big the array was when we started, since there are no more cells there, the loop just ends, and we go down past there. So could you have written this with a for loop? Yes, absolutely. You could have said for int I equals 0, I less than 4, I plus plus, and inside there you could have even said string oneword equals my array at position I. And that would absolutely work, and you would get the same output and everything would be the same. This just automated that process for you. So if you're not comfortable with this, you don't have to use it immediately, but I want you to be aware that it exists, and you certainly could see it on a test or on a quiz. So that is a for loop. They can only be used to iterate over collections, and the definition of a collection for right now for you guys is an array. The only collection you've seen is an array. Later on, you're going to see that there are other collections. One of them is called an array list, if you'd like to go look that up. It's not covered in this class, but you'll see it in other classes. It does something similar to an array, but it has a couple of different changes there. So you can use a for each loop either on an array or later on any other collection type. It is always possible to convert a for each loop into a regular for loop. They are 100% interchangeable. Java knows which one it is based on the parameters that you're passing to the for loop. So for example, this is the syntax for a for loop, where X is the initialization, Y is the test, and Z is the increment. Whereas with a for each loop, this is the type, this is the variable, and this is the collection. And there's a colon in between. So it's really that colon or the two semicolons that tells Java whether you're attempting to write a for loop or a for each loop here. So that's all that's going on in a for each loop. There is one more thought that I would like to bring up, which is you need to be careful with for each loops that you don't change the number of values in the array while you're going through the for each loop. And this is less of an issue with arrays, but when you get to array lists, it's important to realize you can't remove something out of the list while you're going through it. And again, not something that matters right now, but I just wanted to put that seed in the back of your head that you can change values in an array with a for each loop. That's no problem, but you want to be careful about removing or adding things while you're in a for each loop. All right, so we're going to do a challenge. Create an array with the following characters, A, C, E, G, I, K, blah, blah, blah. Count how many vowels are in the array. Use a for each loop. Tell the user how many vowels that you found. So I'm going to go ahead and I'm going to start a replet. I'm going to put those letters into it, and then I'm going to come back to you. Okay, so here we have a replet, and in this replet I have gone ahead and created the array of characters that has A, C, E, G, I, and so on and so forth in there. And so next up what we're going to do is we're supposed to write a method that checks to see how many vowels we have in the array. So a vowel is an A, an E, an I, O, or U. So we're going to go back and we're going to say, using a for each loop, so I'm going to say for parentheses, and then the type of the array is car, and the name of the variable that I'm going to use here is I'm just going to call it one letter, and then colon letters. Letters is the name of my array. So the type, a made-up variable name, followed by the array that we're actually working with. All right, so now as I go through this loop, I have a variable called one letter that will have A in it the first time, it will have C in it the next time, it will have E in it the next time. So what I'm going to do is I'm going to say if one letter, and this is the most important thing about writing a for each loop. Notice that I don't have to say letters at position I, it's automatic. I have something called one letter. So if one letter is equal to A, or one letter is equal to E, or one letter is equal to I, and I probably should be consistent as to whether I'm doing uppercase or lowercase, or one letter is equal to O, and that needs to have two equals. On the previous one, I think I got confused by the extra quote that it put in for me. Or one letter is equal to U. And again, I'm missing a quote here. All right, so if it's A, E, I, O, or U, what I'm going to do is I'm going to add 1 to a variable called numVals. I got there eventually. Plus, plus. All right. Obviously, to be able to use that, I'm going to need to create a onevals or numVals variable. So int numVals equals 0 to start off with. And then down at the very end, I should just be able to print out how many vowels are in here. And so here we have, you have plus numVals vowels. All right, and we're going to hit run. And I don't know how many we actually have in here. It looks like there's 1, there's 2, there's 3, there's 4, there's 5. Okay, I think there are 5 in here. Bad operand types for binary operator OR. All right, and the particular place that it's complaining about is right here at the end, and that's because, again, I did a single equals instead of 2 equals, and so I was trying to do an assignment instead of a test. So that looks like that is done. And cannot find symbol numVals. What did I spell wrong? Yep, I spelled it wrong. There we go. Oops. You have 5 vowels. Okay, and so that's using a for each loop to iterate over an array. A couple of things I want to point out about this particular example. The first is that I need you to understand that there is no rule that says that all arrays are going to be arrays of integers. It is possible to have an array of characters, an array of floats, an array of doubles, an array of booleans, an array of strings. Any type that you have seen, you can make an array of. So this is perfectly valid to have an array of characters and to use a for loop to go over them. In the previous example on the slides, we had an array of strings and we used a for each loop to go over them. And we could do the same thing with numbers. We could do the same things with floats. So any of the above are absolutely possible. The other thing to notice about this is that ends up being a little bit shorter than if I had written it the other way, where I'd put int I equals 0, I less than letters.length, I plus plus. One letter is equal to letters at position I, and then do the if statement. So I eliminated a lot of that. And it's also just cleaner. It kind of reads in English for each character in one letter. For each character in letters called one letter, do this loop is effectively how you would read it. Okay, so hopefully that makes sense. Back over in the slides here, we have that example coded out as well, so that you can reference it just from the slide deck. And there it is there. Looks like I called everything the same thing. So that's, I think, identical code. All right, so that brings us to a comment, which is that by now you're probably wondering, well, wait a minute, are strings really just arrays of characters? And the answer is a little bit nuanced. It's not exactly an array of characters, but it sure looks like an array of characters. So you could have string A equals happy, and that certainly is valid. And then you could also have car array B is equal to new car H, A, P, P, and Y, and that is also valid. So the first one is a string, the second one is an array of characters, and they are technically two different types, but they're so close to each other, there's actually a way you can convert back and forth. So down here in the bottom of the slide, I said car array C is equal to A.2car array. So let me break that down for you and talk about what's happening here. So we have a new character array, which I'm calling C, and I'm assigning to it A, which as you remember is a string, dot to car array. So this is a method or a function that's built into strings that allows you to just convert them into a character array. And it's called toChar array, which makes some sense. So a.toChar array gives you back an array of characters, and I'm assigning that to car C. And if we want to go the other way, remember that we have a character array called B, that's an array of characters, and I can ask it to give me a string.value of B, and that will give me back a string. So I can assign that to a string. So it's absolutely possible to convert between an array of characters and a string, or a string into an array of characters. And sometimes it's convenient to think of them either way. For example, if I wanted to check if a particular character was in a string, I might want to make it into an array of characters and then use a Foreach loop to go find that particular thing in there. And as a matter of fact, I think that's what we're going to do as our next coding challenge. Sometimes you'll need to search a string for something. Write a program which defines a string, cherry, check if it contains an R or a Q, convert the string to an array of characters, use a for or Foreach loop to iterate over the array to see if what you're looking for is in there. All right, so again, we're going to start off in a replet. There's going to be a string called cherry, and we're going to have to convert that. So I'm going to pause and get you a new replet. Okay, so here's a fresh replet. We're supposed to start off with a string, so string, and we'll call it test word is equal to cherry. All right, and then I'm supposed to use a for each loop to go through that array of characters and see if there's an R or a Q in there. Well, the problem is it's not currently an array of characters. So in order to be able to do this, I need to convert it to an array of characters. So I'm going to say car, square brackets because it's an array, and I'm going to call it test word array equals test word dot to car array, which is the method that converts it into a character array. So now I have an array of characters. For car, because that's the type of my array of characters, and I'm going to call it, let's just do X for now, colon test word array, which is the name of the array of characters. If X is equal to, I think I was supposed to check for R or Q. If X is equal to R or X is equal to Q, then we're supposed to print founded, I guess. Okay, so if we run this guy, we took the word cherry. You're going to find two R's in there, apparently. So it's going to twice print out found an RRQ. And there it is. So as we can see, the for each loop is going through each of the letters and it's checking it. And just to prove that point, what I'm going to do is I'm just going to add in a print statement, system.out.println, and I'm going to say checking, and then I'm going to tell you which particular letter it's checking, which is known as X to this loop. So you can use the X as many times as you want inside the loop, and you can see this is going to say checking C, checking H, checking E, and then when it says checking R, it's going to say found an R or Q. And then checking R, found an R or Q, checking Y, and didn't find an R or Q. So this is a really easy way of going through a string and looking for something inside of that string. And if you were asked to count how many times it happened, you would just use a counter. So there's all kinds of cool things you could do there with that. So next off, we're going to take a look at the solution that we have in the slides, which is very similar to what I just wrote, but it has a couple of minor differences. So we start off with the array, which is created from the string. So we have a string and then we have a character array. And then what I'm going to do here is I'm going to actually keep track of if there's an R or a Q in there separately. So I did this with Booleans. So I have a Boolean found R and found Q, which both initially start off as false. And then I'm going to use a for each loop, which goes from here to here, which is going to go through each letter of the letters array. And the letters array is the array that we created up here. All right, so it's going to go through the array one at a time, and it's going to look at each letter. So as we go through here, we check to see if the letter is equal to R, then found R is true, and if the letter is equal to Q, then found Q is true. And at the end of this for loop, I then just have an if statement that says, if we found both, tell them that we found both, otherwise tell them that it doesn't contain R and Q. So the difference between what I did in the code in Replit and what I did here is, this is more specific. It will only accept if there's an R and a Q in here. So if you run this with this exact example, it will tell you, no, there's not an R and a Q, because there aren't. There's R's, but there's no Q's. So this is a slightly different version of the code that I wrote, but you've now seen two different ways that you can use a for each loop in there to code this. Okay, so next up we are going to take a look at a word that's circulating around at the moment called Wordle. So Wordle is a game which, if you've never played it before, the URL for the game is down here at the bottom. And basically how it works is you have to guess a 5-letter word. And every day there's a different 5-letter word, and they give you 6 guesses to guess the 5-letter word. Well, on each of the guesses, they tell you whether the word was correct. If not correct, they tell you, did you get any of the letters in the correct place? And if you didn't get any in the correct place, it tells you, did you get any of the letters that are correct at all? And what I mean by that is, did you pick a letter that's in the word but didn't put it in the right place? So here's an example play of it. So this was a couple of weeks ago, I guess. So we start off and you make your first guess. And for me, what I guessed was chair. So you'll notice that it highlighted this R in green. That tells me that not only is there an R in the word, but it's actually in that last place. There may be more than one R, but at least it tells me that that R is in that location. So then with that, I tried to think of another 5-letter word, and they all have to be words that you type in. So I came up with color. Well, again, that has an R in that position, which I knew was going to be right, but obviously I wanted to pick letters that were different for the other locations, which I got 3 out of 4, so not terrible. All right, so the O in that case was correct. So now I know that there's an O in the second position and an R in the third position. So I tried to think of other words that would have that, and I came up with toner, Toner, and it looks like that had 3 that were correct. Then I tried gopher. So gopher, it told me that there's an F in the word, but it's not in that location. And since that was true, I knew at that point it was F-O something E-R. And so the only word I could think of for that was foyer, and that turns out to be the right word. So this is how you play the game. And what we're going to do is we're going to write this game in Java. So we're going to do it in a text way. It's not going to do all the colors on the screen because we haven't gotten to that yet, but we're going to write it so that it has just text that tells you, yes, those letters are in there, no, those are not. So you're going to need a bunch of different loops. You're going to need one loop to give them 6 guesses. All right, and if it's going to go 6 times exactly, and that is the rule, you only get 6 tries. You notice that there was one more try and then I was done. At the end of the 6th try, it's going to end either way. So this loop is going to go exactly 6 times, and since we know how many times it's going to go, that sounds like it's going to be a for loop. We're going to need a loop to ensure that each guess they gave us is valid, insofar as it has to be 5 letters. So if they give me something that's not 5 letters, I'm going to need to keep asking them to give me something that has 5 letters. Theoretically, I should also be checking that each thing that they gave me is a word. But that's slightly beyond the scope of the class right now, so we're not going to worry about that. We're just going to allow them to type in 5 random letters, which is not exactly right. Then we're going to need to have a loop that checks each character in their guess to see if it's correct, meaning that the whole word is correct, or if it's in the word but in the wrong position. So those are the different parts of what we're going to do. And so here is some sample output. What is your guess number 1? They type in chair, and it's going to tell you R is in the word in position 5. What's your guess number 2? It says color, and it says, okay, O is in the word in position 2, O is somewhere in the word, and R is in the word in position 5. So you might wonder why it said 2 things about O. Well, because I'm checking them individually. It is true that O is in the second position. That part is correct. But then when it got to the other O that's down here at the end, it said, well, there is an O somewhere in the word, but it's not supposed to be right here. So that's a little weird, but that is how it turned out. And then third guess, fourth guess, fifth guess. So rather than me sitting here and coding this, I'm just going to show you the code for this one, and I'm going to go through it because there's a fair amount happening in here. So let's begin at the beginning here, and we have obviously our main method that starts right there. And I'm going to need a scanner because I'm going to allow them to type in stuff, so I need the usual import of scanner and the creation of a scanner object. And then at some point at the beginning of the code, I need to set what the actual word is that we are searching for, which in this case is going to be foyer. So I'm coding it exactly from the example that you saw on the slide. All right, so the first thing that I need to do from that is I need to convert the secret into an array of characters. So that's the same as what we just saw. Secret string equals 2-character array, and that produces for me an array of characters called secret. Then I'm using a for loop, and in this case it is actually a for loop, and it's going to run all the way down to here. So it's a big long for loop. It's going to go 6 times, I equals 1, I less than 7, I plus plus. Now you might wonder, why didn't I start with I equals 0? Well, because I want to tell them this is your guess number 1, this is your guess number 2. And I don't want to start with this is your guess number 0, that's not good for humans. So I started with I equals 1, I less than 7, which will go 6 times, 1, 2, 3, 4, 5, and 6. By the time I is 7, it's not less than 7, so the loop would have stopped. All right, so next up, I then have a variable called guess, which is what they're going to type in as their guess. So I have a do loop, and this do loop is to make sure that what they gave me is actually 5 characters long. So I ask them, what is your guess? And then I read in their next line, and I store that in guess. And then I keep doing that as long as their guess is not 5 characters long. So we haven't really talked about this, but an array, you can check its length by simply, a string, you can check its length by simply doing string.length with parentheses. It works just like an array length, except for strings you weirdly have to put parentheses after the word length, whereas with array lengths you don't put it in there, which will always be confusing. So this loop is going to keep asking them to enter in a 5-letter word until they give us a 5-letter word. Once they've given us a 5-letter word, we're going to move on and we're going to check to see, did they get it right? Okay, if they got the correct word, we're just going to stop, because at that point, they gave us the right answer. So we tell them, great, you guessed the word, and we break, which is going to break us out of this for loop. So that will end the program effectively, because the for loop is the whole program. All right, so presuming that they didn't give us the right word, then we are now into an else condition. So we're going to start off with position equals 1, and what we're going to do is we're going to go through the letters in the word, and we're going to check to see if each letter is in the word in the correct position. All right, so this is what this first loop is going to check. So it's a for each loop. We convert their guess into another character array, and we go 1 letter at a time with the for loop over that character array. And so we check if the secret position minus 1, so the secret you'll remember is the actual word foyer. So we're checking if position minus 1 is equal to the letter that they gave us. Now you might say, well, why position minus 1? Well, because the character array that holds their guess, we are starting off at position 1, because I want to tell them it's in position 1. Again, I want to tell the human it's in position 1, but in reality it's in position 0. So I'm checking to see if the secret position at position 0 is equal to the first letter in their guess. So basically I'm checking the first letter they gave me and the first letter in secret string, and I'm seeing if they are the same. If they are the same, then I print out F is in the word in position 1. If they are not the same, then we move on to the next letter and we check that. So this loop will basically tell them if any of the letters they guessed are correct and in the right position. Now, if that's not true, then the next thing we're going to check is it in the word at all? Meaning, did they give me a letter that's anywhere in the word? So what I do here is I take each of the letters, and one at a time as I'm going through this is inside this for each loop, so I still have G letter. You'll notice that this if and else are all inside this for loop. Okay, so what I'm going to do is I'm going to say, if the letter is not in the right position, then I'm going to look through all the letters in the secret, and I'm going to see if any of those match the letter that they gave me. So it's basically going to start at position 0 and see if it's in there, 1, 2, 3, 4, 5. If it happens to be anywhere in the string, then I'm going to tell them, yes, there's a P in here, but it's not where you think it is. And so that's what's printing that out. And then at the end of all of this in the loop, I simply change the position up to go to the next position. I'm noticing that I drew the for loop a little bit too quickly. That's the actual for loop. This is the if, and that's the else. There's a nested if inside this if. So there's a lot going on in this code, but I think you can understand that each of those things is individually solvable. All that's happening in this last one is to see if one letter is inside of an array. And that's what I coded earlier, so that part's actually pretty easy. This one is just checking to see, is a particular letter in the same exact position in a different array? And that's actually pretty easy as well. And then over here, we were just checking, are the two strings equal? So that's really easy. You've seen that before. And then here, we're just making sure that the length of what they gave us is a 5, so that they're actually giving us the right length word. So that's actually pretty easy. It's just when you put all this together, it's suddenly able to do something pretty cool. And so the only thing that's really limiting about this game is that we hard-coded the word foyer. So every time you play it right now, it will always pick foyer as the word. And what you'd probably want to do is use a random number generator to pick a word out of a long list of words. Maybe you'd have an array of strings that was all of the possible words that it can choose from. And at the beginning of the program, it would pick one cell out of there, and that would be the word. That would actually make it quite challenging, and you'd have a pretty fun game that you've written. So you can play with that on your own if you wish to go off and do that. But the code that's here should work, and you should be able to take that, and that will give you a good starting position. So that's the Wordle game, and that is the end of lecture number 3 with regard to arrays. You've pretty much seen all the different parts of arrays. We're going to do one more example with arrays using a sort algorithm in the next section. So I will see you in arrays part 4.